Okay. Um, Good afternoon, everyone. And today's lecture, we are going to continue the uh, the last chapter, the chapter 5, the integral, the fundamental theorem of calculus, and maybe we are going to uh, finish today until substitutions method. So before we start the lecture, for some students, I have seen the score from your TA, and until I see all the scores, from what I found, maybe I will offer you makeup exam, but we will have a different percentage. Okay, I will think how many percentage you will have, like maybe uh, 40, 60, 60 from the new one, 40 from the previous score, maybe that way. Okay, so maybe I will write here. Okay. But I will let you know, okay? I will let you know the date and when we will have the makeup exam if we have, okay? But I still need to check all the scores. I just check like maybe 10 or 10, 12 students. So if we have makeup exam, this will result to maybe 40 to this is 40 the previous score and 60 the new score. If not, maybe 45 or maybe 35 here. 35, this is 65. I think it's okay. And it will be optional, okay? But of course, if you have like maybe if your score maybe below 40 or maybe below 30, I think it's better to join the makeup exam. But this will be later will be informed, okay? After I deliver your final score for the midterm, okay? And at the end of the lecture, I will give you some survey about your feelings about our last midterm. Okay? I need to know which part that we need to improve. Okay. Okay. Aside from the difficult questions, okay, maybe we need to improve with the time or maybe the quality. Okay. So that will be related to the makeup exam. Okay. Okay, that's the first information. Okay, okay. I hope you already scanned the QR code. Okay, for also for the online students. Okay, but I think makeup exam maybe if I take a look my schedule, and because there are several students who are coming late, so I think we need to wait for them. Okay, maybe this makeup exam maybe after December 21st. So in between this, okay, and the students who are just coming late, I will also give you the how to solve our midterm, our last midterm. Okay, so maybe next week I will prepare the video and I will later upload, and I hope you can learn from those videos. And maybe the mega exam is because we don't really have much uh, time for the weekday. So maybe in the weekend, maybe in the Saturday, maybe in Saturday. Okay. I hope you have flexible schedule on Saturday. Okay. I will ask later the details and the time, the place. Okay. Okay. That is about our midterm and maybe our plan if we have the makeup exam. Okay, because from what I've seen, I think maybe we need to take one. Yeah. Maybe my questions is like so uh so you are here. And my question is here. Okay. Joke aside, if you get like really bad scores, okay, in my class, don't take really uh, personally. Okay, don't really take that score personally. Uh, for me, the best way to achieve a good performance is not a score, okay, but by improvement. Okay, because I'm not sure how we are, because this is our system, our academic systems. Uh, we have different background, we have different maybe interest, passion also, um, but somehow our curriculum make us into uh, at least having one simple standards. That is, I think we need to have more variables in um, calculating the students' performance. Okay, not only like just exam, but I think we need to have more variety uh, to evaluate the students. Okay, so I also will include other evaluations. Okay, your attitude in class and uh, performance on how you study. Okay, I also ask your TA how the students improve. Okay, for example, okay, the starter, the students get maybe 60. Uh, let's take this case. Okay, student A gets 60, student B get maybe 35. Okay, this is maybe the quiz. On quiz two, still this is just 61. Maybe this got getting maybe 50. And maybe the quiz three, this will be maybe still 6 maybe, and maybe this will be maybe 71. Okay, if we take uh, some difference here, I think student B improves a lot, right? And this increase point, I will also consider as another point as well for the students. Okay, so if anything happen in your midterm score, okay, we still have another way to evaluate. Okay, not the end of your calculus. Okay, even though maybe midterm have some percentage, we still have another way to evaluate. Okay, okay, and also I will consider the makeup exam for you to think and maybe consider to take one as well. And for the other students who are maybe already, maybe he already got maybe 80 or 90, it's still up to them if they want to take the makeup exam or not. Okay. But I think for the one who are below, maybe below 40, I think they need to take this makeup exam. Okay. Okay. That's just a brief talk about what should we do next and how do we prepare our next lecture and also next evaluations such as the exam and other evaluation as well. Okay, let's continue our lecture. Start from the last part that we are discussing is the fundamental theorem of calculus. Okay. Okay, so we start from the first one here. This is the summary of what we are doing last week. Okay, the uh, the functions. Suppose the functions f is continuous. Okay, and if you have gx here, this is equal to the integrations from a to x of f. Okay, so this is, if you remember, we are treating the area as a function. So gx is the area under the curve, right? So let me write here. Okay. So first, this is A, this is B. Okay, we evaluate from A to B, but gx is, maybe I will change the color. Gx is maybe here, and this is x. Okay. So the one that I colored with green is the area of G, which is this is f of t, this is t, and this is y. Okay. Okay. And when we have the uh, g prime, if we differentiate, it become just f of x. And we already proved how we are having these integrations, and when we differentiate, it just become f of x. Okay. Let me give you the some example on how in practical we are using this theorem. Okay. So for example, if you have example, so if let's say start from 0 to x, and we have 1 plus t squared dt. If you need to take derivative, okay, like g prime, okay. So the first derivative of g, the idea is, if you look at the theorem, if you have the integrations you want to derive, basically what you're going to do is take this x, take inside here. Okay? That's the first case. So this will be okay. Okay. Now that is how we are going to use the fundamental theorem of calculus in practicality. You can also write in a complete process by writing like by fundamental theorem of calculus, then the g prime, blah blah blah. Uh, but you can do just directly derive like this, or if you want to write, that's also okay. By fundamental FTOC is fundamental theorem of calculus. Okay. What is going if you have, what will happen if you have this 2x, same functions. What is the first derivative of g? Any idea? Just guess how. Any idea? Yes? Yes, and then other and then uh, this zero or any other constant, it will be gone. It will be gone. Yeah. So we're just concentrating on variable here. Okay. Okay. First, if you feel confused, uh, let's take this x. Okay. Let's turn into maybe u. If this is just u, just one variable, we just take this inside, right? Okay. Then the first thing we did is we derive with respect to u. Okay. But u itself is a function of x. So if I write let me write here. Or maybe let me write one by one. Okay, and we need to multiply because we need to have t prime x. We need to multiply with. Okay, let me zoom in so that you. Okay, so if we take the 2x replace with u, we are going to have this u. We take this, differentiate. It's the same way when we did the previous one. Take u inside, u squared. Okay, this will become 1 plus u squared, right? This will be 1 plus u squared. And du dx will be 2, right? Or if we are going to revert back to x, this will be 1 plus 4x squared. Okay. So how this happen? This is chain rule. This just a normal chain rule. Just a normal chain rule. In the conclusions, the short way to doing this is if you have any functions, not g, maybe h. Maybe f, c, this is become, okay, okay. So this is we apply the chain rule, similar way with what we did in chapter 3. So the idea is put in here, this h put inside, and then this h need to derive, multiply and derive. Okay, that's how we are going to. Okay. And the bottom part here, it can be any constant, like 1, 2, 3, 4. We can ignore this part because last week I think we have seen that any a that a is constant, we can ignore because at the end they will subtract it by themselves. Okay. Okay. Since this is the first derivative, right? Let me write here. Since this is the first derivative, right? The first derivative. all your knowledge on chapter 3. Chapter 3. Maybe we will have some questions related. Chapter 3 and 4. Chapter 3 and 4. So the questions like find the tangent line, find increase, decrease, concavity. Okay. Still the same questions like chapter 3 or 4. But the difference, the function is maybe having this integral. Okay. 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 Now, if we look back the theorem again, the second one here, this is just if we have these integrations of a functions from A to B, we are taking these functions to its antiderivative, or we integrate, okay, this endpoint B minus the endpoint A. Okay, I think this is already familiar with all of you. And this capital F is antiderivative of F, that is this big F prime is equal F. Okay. This is actually similar to what we have done in the first part here, but we are looking at this this integrations process. Okay. If we are going to have some example, that I think from the simplest one, like maybe integral from 3 to 6 of dx over x. Okay. So if we're going to see that the functions is 1 over x, okay, if you want to write down one by one, then its antiderivative is ln, right? Ln what? Ln x. Don't forget to write, yes, the absolute value. Okay. Don't forget to have the absolute value. This absolute value is important. Okay. So you have 3, 6 dx over x. This will become ln x from 3 to 6. Okay, because I know that will be positive, so I remove the absolute value. This will be ln 6 minus ln 3, or ln 2, right? Okay. Okay, I think nothing wrong with that. And also, we have the integration of this, right? The power. Okay. this will be resulting x n plus 1 n plus 1 plus 1 plus c. Okay, and we already arrive at this conclusion at chapter 4 antiderivative. Okay, okay, if we have an example, let's see. Okay, another example. Okay, can you compute this? Can you try to familiarize with the integral? Okay. Mm-hmm. Okay, okay. Okay, for online students, you can write your answer in the chat box, or if you have any other idea, you can write on the chat box. Okay. What's your answer? Mm-hmm. You can compute. Can you? 2 over 3. Okay. Okay. Mm-hmm. 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 Okay. What's your result? Yeah, minus 4 over 3. Okay. Okay. If you check the results, okay. Online students, do you have any other idea? Okay. Maybe what's your calculations? Is it 2 over 3 or negative 4 over 3? Okay. 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 Good. Good. Okay. Let me explain. So this part here, okay, this is we can write the function as x with the power of negative 2. Then we have the antiderivative is x minus 1 divided by minus 1, right? This is we evaluate from negative 1 to 3, which is we can compute that this will be negative 1 over 3 minus 1, so it's 1, right? So we can have this result. Okay. Now my questions, is this correct? Oh, really? Really? This is minus going here, it's plus 1. Plus 1, right? Minus 1, right? Okay. The calculation is correct. But the whole integration is wrong. Do you know why? Anyone can point out why this is wrong? the calculation is correct. Okay, if you have without any number here, it's correct. Okay, but this is wrong. Anyone know? Anyone know why? Ah, good, good, good. See, -1, 2, 3. If you have the interval, you have -1, 0, 1, right? Can x be 0 here? It's not continuous. So the integration did not exist. Okay. So this is an so this integral. This is does not exist. Okay. 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 So this is a tricky question for you. Okay. Because at x equals 0, the function is not continuous. Okay. But at the chapter 7, next, I think next 2 chapters, we will learn how to approximate. It is called the improper integral. The improper integral. But this will be still later. Okay, still later. Maybe at the end of December, maybe we will learn. Okay. Near the end of our semester, we will learn improper integral. Okay. 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 Online students, you got this idea. Okay. So careful on the domain. Continuity still plays important roles in integration. Okay. Okay. Let me check. I can give you a few example on the fundamental theorem of calculus. Okay, let me check the question first. Okay, let me give you a few example. Okay, compute the integrations. Find the first derivative, I think. Yeah, from this function. Mm, this is A, and the other one is B. Okay, two questions first. Okay. Okay, you get the results. Okay, and for B, not yet. Okay, and for A, okay, you just substitute square root of x to t, right? And then don't forget to multiply with the chain rule. Okay, I think that will be the first one. And how about the second one, the p? Mm-hmm. Okay. First one, can you try? First one. Mm-hmm, mm-hmm. Okay, okay. Okay. The idea of the fundamental theorem of calculus is if you have a functions with the integrations and you want to derive those functions, okay, when you derive, okay, when you derive, what you are going to do is substitute the variables, right? Substitute the variables. So for example, this is a constant. We can ignore the constant. Substitute the variables here, and then multiply with the chain rule. Okay, multiply the chain rule. But what happens if we switch this? Still, we are need to consider the variable, the x. Okay. But to avoid mistake, let's just switch this two, and it's become minus. Okay, we can do that in integral. So okay, I will start from A first, and then I will turn to B. Okay, so first for this one, we can let me write uh, step by step. And multiply with 1 over 2 squared of x. This is become x squared plus 1. Or maybe, yeah, I think just this, I think this is just okay. Okay, now this one, first we need to switch. This become 5 over 4, become squared of x. Now from here, we can find the first derivative, still negative, and then we compute this. Okay. And then we divide by 2, right? And this, and the results will be minus half tangent squared of x. Okay. 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 Okay, give you more questions. Okay, C. Okay, let's say we have g of x. This is 1 minus 2x. Okay, have g from 1 minus 2x to 1 plus 2x of t sine t dt. G prime x is equal. Okay, let me give you some time to think and work on. Okay, so first, the problem is now you have this x, this is also x, right? If one of them variables, one of them is constant, maybe this, if this is 0, the bottom one is 0, and the upper is 1 plus 2x, you can do it easily, right? But what happens if this is happening, right? 1 minus 2x and then 1 plus 2x. Okay, any idea? Mm-hmm. Mm-hmm. I think first, before thinking about the functions, think about this first. What will you do from here? Idea? Yes, yes, yes. Yes, correct. Okay. So, because from the first one, okay, this is still in line with our first problem. Okay, look at the first problem here. Okay, we have constant variables, variables constant. Okay, what happens if we have two variables in this integration? We need to make them constant, or we need to prove that there is some constant in between these two. Okay, we need to have that as well. So let me write here. We need to prove that in between these two, that there will be a constant c. Okay, there will be a constant c. And I think, and if also if you think that maybe that c is probably 0, right? 0 is in between this and this, right? If you think carefully, okay? 0 is in between these two. So what I can write here is we separate the integral. Okay, and then we switch this one into 0 to 1 minus 2x. This has become negative. And this will be okay. And the rest, I think we just follow up what we have learned before. We are going to have, let's write minus and then put inside 2x sine and multiply with -2. I will write become 2 outside here. Okay. And plus 1 plus 2x sine 1 plus 2x and multiply by 2. This is also 2. I think this will be the results. Okay. Okay. I think I can give you one more question and we can continue a little bit. Another example. If f(x) is okay. This is actually a question from chapter 4, but in the form of the integral. I hope you still remember the increasing, decreasing functions. It's from chapter 4. Okay, wait. Why there is call? Sorry. Okay. Mhm. And then what? Okay. Okay. Mm-hmm. And it is right. Yeah. Okay. Okay. Good. Mm-hmm. You need to remember what this increasing means with the first derivative, right? Okay. 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 So I think some of you are already doing a good job. So first, increasing means that the first derivative should be a positive, right? Or the slope is positive. It's getting higher, right? So the first derivative from these functions is we're just taking inside the x, and then this will become ex squared. Okay. Okay. Now let's take some logical reasoning. Okay. Because I believe you think that maybe e will be a problem. Okay. E is a constant, right? It's a constant, 2.7 something, right? X, it can be zeros, negative, positive. But when you apply all numbers of x, can this part become negative? It's always positive, right? Okay, that's the first thing to remember. So this is always positive. So the problem is we are just having now this 1 minus x squared. If we want to find the critical point, if you would like to equal this to 0, this will be resulted with plus minus 1. And as I mentioned earlier in the chapter 4, or maybe before that, always make the line number to make sure your answer is correct. So this is negative 1. This is 1. Okay. Check all possible things from here, from here. And I think that the only positive is only in the middle. So the function is increasing from negative 1 to 1, right? So this will be a negative, will be positive, will be negative. So it's going up. Sorry, it's going down, it's going up, it's going down, right? So we will have that f increasing on okay. Okay, I think that's enough for the example for this chapter. We will have another example if we have time, maybe next week or maybe before another exam, maybe quiz. Okay, but I think we will have maybe next. I think 2 or 3 weeks. Okay, I think we can go for another sections in our chapter. Okay. Before we go, any questions first? Any questions? Or do you want still to take notes from previous? Or you want to take notes from here? Okay, maybe the online students, if you have any questions, you can write on the chat box. Okay. From the classroom, any questions from previous one? Okay. Okay, I think I will give you some exercise from textbook so you can look the questions. Okay, now we can move to another chapter, 5.4. But this is just a brief, just a short chapter because we already mentioned mostly in chapter 4 antiderivative. Okay, so indefinite integral, we have these relations. Okay. Okay, from fundamental theorem of calculus, we also have this reasoning. Okay, So between definite integral and indefinite integral, one way to separate those two is by looking at the definite integral is having a number as a result, while the indefinite integral is a function. So when you have the integral f of x dx, I already write, I already write in the first one. So when you have integral of f of x dx, this will be result in an antiderivative, and it's a function. It's a function. However, these two can be connected. Okay, these two can connect each other because it's still the integral. That is, if we have integrations from a to b from the definite integral, that this is actually indefinite integral with the evaluation from a to b. And I think it's already guys already familiar with this one. Okay. Or we can say that this is the same way as this. Okay. And I will write some important integral, okay, for you. So if you have k dx, this will be, k is a constant, so this will be kx plus c. Okay, and fine. And also the 1 over x dx. Also the b with power of x. This is b and b. And then secant square. Okay, several important integral, indefinite integral that is probably you already know how to integrate this. But to help you learn or to help you study, you can think from the results, okay? Because you know the derivative, right? And derivative is much more easier than the integral, right? And you can think from the right side, from e, from cosine, tangent, tangent inverse. You derive, it became the left part, right? Okay. And the way you are thinking forward, backward, derivative, integral, it will help you uh, to make some conclusions or to make some logical reasoning when you are dealing with some problems, especially in integral. Because to solve some integral problem, you need to have the knowledge of the derivative. Okay, the knowledge of derivative. Okay. Okay. So whenever you have something in mind, you feel nervous, you feel not sure. If you integrate, then you take the derivative and check whether it's going back to the original part or no. If it is, then it's correct. Okay. That's one way to check um, our progress or our results. Okay, so this is 5.4. Not really much going on in this 5.4 aside from how to solve some graph and relate to some physics phenomena like a distance velocity problem. So that I will skip that on, and we can go forward to 5.5, the substitutions rule. Okay. Now it's almost 2:30. Okay, let me finish the substitutions rule for just a intro and some example. Okay. Okay, substitutions rule. So before we substitutions rule, let me write again what's important in the integral. Right, we always start with this for integral. Okay, okay, let me write if if f of x is, let's say, tangent, and then we have x with power of 4. Okay. And let's say we want to derive. What's the derivative of tangent? Tangent and then x with power of 4. What's the derivative? Tangent becomes what? Secant, right? Okay, secant squared. Okay, secant squared. Okay, so secant squared, and then multiply with the chain rule, right? Okay. Okay. In doing this chain rule, if you remember, the first time I show you that maybe we need to take this into some form of u, right? So we are going to have if we have this is u, okay, this will be secant squared u, right? But we have f prime x, or I think I will write directly for that, and this is multiplied with du dx, right? This is du dx is 4x cubed. So that's why this is 4x cubed. Okay. Remember this process. Okay. Remember this process. We are using the chain rule. Substitute some variables here with another variable to help us simplify the process. But we still need to compute the chain rule here, and we have this is our results. Okay. 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 Same way. If we have integral 4x cubed secant squared x with power of 4 dx. Of course, based on our results from the previous one, this should be resulting the tangent, right? The tangent x with power of 4. Okay, this should be resulting back to here. Okay, so The same way with the previous one, we need to assume some variable. So we need to choose or identify which one we are going to select. Okay? So let's say we have u. So we need to have u so that we can have all terms in these integrations become u. Okay. So if we select just like this one here, we select this same one as the derivative here. If we select this, then we also have du dx is 4x cubed, and we can switch the dx become 1 over 4x cubed du. Okay. Now let's change all terms with u. All terms with u. This will be 4x cubed divided by 4x cubed from the dx, and the secant will be secant squared u du, and then this will be cancelled. Okay, and this is precisely become a tangent u, right? Secant squared u become tangent u, and u is x to the power of 4. Then this will be tangent. Let's revert back to the original one plus c. Well, you can still write maybe, but this is just my opinion. In my opinion, usually you write this first, right? Tangent u plus c, and then you revert and then change to x with power of 4. But in my opinion, this constant here is not the same. So I think better just stick with the original one. Okay, so that's what we call the U-substitutions or substitutions method, because actually you can substitute with any variable, any variable. Okay. What's the principal idea? The principle is we need to select, okay, which part in our integral. When we select this part, the derivative of those u will cancel some part of the integral, and it will be, for example, this one. Okay, let me review this. We select u x with power of 4. Why we need to select this? Because if we take the derivative, it will be 4x cubed. And if we exchange the x, it will be 1 over 4x cubed. So that this part will cancel this. And the whole integral would be u. That's successful for u substitution. If you use substitutions, at this part, you still have x left, then you cannot use the substitution because you have x and u at the same time. That's not really ideal situation for substitutions method. Okay. Okay. Okay, that's the substitutions. Let me go through a little bit some examples, okay, to see whether you are clear or understand the idea. Okay. Let me go through the next page. Okay, let me write x. Okay, I think this integral is not good. Okay. Okay, start with the x over square root 1 plus x squared. Okay. If you have too much work, then maybe you select wrong u. Okay. Square root. Okay. Okay. Good. Ah, good. Good. Yes. Good. Very good. You try to reverse, try derivative, right? Yeah. Good. Good. Okay. Mm-hmm. Okay. Mm-hmm. Okay. Okay. Reverse. Okay. We have a fraction. Okay. X on the top, one plus square root of 1 plus x squared on the bottom. Okay. First, okay, before you start doing some calculation that you are not really sure, look at this x and look at this square. Okay. Which one of this, if you derive, you can cancel? Which one? This one or this one? Up or down? A or B? Which one? Okay, you. Which one? If you want to select some parts, you want to cancel, which one you select? Up or down? A or B? Hmm? You want to cancel that? Or which one? Here, you have x. Okay, let me remove just the square root. This 1 plus x squared. Okay. If I would like to select u to substitute, to cancel one of this, okay, which one? Down, right? Okay, clear? Because I see some your notes that you're still confused on how we are going to do this. Okay, So the idea is we select this because if we select this, we have this, right? Okay, click. So because of this, remit this du and dx will be 1 over 2x du. So that's why we will cancel this, and this will be 1 over u. Okay. Same way, if we have this square root, then this is the square root, right? Okay. Okay, that's the deal. Okay. So if we are going to select u, then we can do with 1 plus x squared. That is still easy to follow. Then we can have this 2x dx. And this will be that. So this will be x over 2x. And this will be over 1 squared of u du. Okay. So this will be canceled. We'll write half outside there. And this will be result with, let me write like this. And we can have this square root of u plus 1. This is plus 1. So it will be another 2. So we will have u square root of u, right? Or u half, or let me write completely as 1 plus x squared plus c. Okay. Okay, let me write this as first method. Okay. 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 Another one. Okay. We can write this as just take this whole thing with a square. Okay. Take this squared, and then this will be this. Okay. Okay. And then we can write this as this. Okay. Right. Okay. And then we can simply change this. Okay. So 2u du 2x dx. Okay. And we can change the results here. Let me write x and then u, and then the x will be u over x. Dx u over x du. One plus x squared. Wait. Did I make a mistake here? Let me check. Oh yeah. Yeah. 10 squared du. And this is u plus c. Or this is, oh yeah. This is 1 plus x squared plus c. Okay. Yeah, correct. And I think the second method is way clean than the first one. Okay, at least from the integrations part. Okay. Okay. Okay, get it? Understand? If you cannot solve this u, the second part of the semester is really hard. I tell you now, this is really hard. Okay. So please take a time for practice. Look your notes. Okay. Take some time to practice. At least doing these two parts, or the first one here is, I think, usually most of the students will do. Okay, the first one here. The second one, a few students will do, and it will be, I think, easier than the first one. Okay. But however, I will show you the last one that I see one student doing this one. So if you have this, okay, okay, think a function that when you derive, it will be here. Okay, let me start with this. Okay, okay, it's let's say this f is, or maybe from here. So let's say this is, we want to find the functions and we want to find the derivative. So the derivative should be resulting this. Okay. What kind of functions that have square root at the bottom? Probably this having square root. Okay, let's check one by one. So checking this. For example, if f is square root of x, okay, f prime is 1 over 2 square root of x. Okay. Now we have square root, square root. Okay, it's looking good. It's looking good. How about we have x squared? This will be 1 over, let's say this is square root, right? And then squared. Okay, and then we need to multiply with 2x. Okay. Okay, looking good. We have x now similar. Plus 1. Plus 1. And we now find our function. And in my case, in our course, you can use this method. And it will be much, much faster. If you can do it in your mind, okay, you're thinking before you write, maybe you already got the answer first here. This is called advanced guessing. Actually, trying some functions and trying derive, try another function derive, try other functions derive, and you get this part. Okay. Okay. So the answer you get, this is plus c. This is the answer. The same answer. Okay, if you have e with power of 6x dx, what will be the integration? Remember, if you have derivative, okay, if you have derivative, we can think this. Let me write this. The derivative will be multiplied by 6, right? But if this is the integrations, then this need to be defined. Okay, we need to take this out, right? Okay, so this will be okay. Okay, okay, give you more idea. So integrations x e negative x squared dx. Plus the integration. Remember, any functions with e, if you derive, it's still e. If you integrate, it will be still e. Think some functions, when you derive, it's become this. course, you can start from this e with power of negative x squared. Start from here. Okay, this is now related with any method that in your textbook. Okay, this is logical reasoning that I told. Okay. At some university, they have explained this a lot. Okay, you can. I think some old YouTube video in MIT, they teach this. Simple method, but really helpful. So first, okay, imagine you have e. You try to derive. Derive becomes negative to x. Okay, similar, but this is having 2. So what we are going to do? Divide by 2. Okay, so this will be negative x e plus c. Okay, so you can have some results directly. Okay, so whenever you find integral, you can always try this guessing method. So my preference, try the guessing method. The second one, try the u-substitution. And the third one, you can think later part, we will have a formula or a method called the integration by parts. Oh yeah, right. Right. Okay. Okay. So what time is it? 2:48. Okay. Still have okay. Okay. The next part is um, some example. Then I think this example is, I believe, is important. Integral of tangent x dx. And um, another thinking, if you have integral of secant x dx. Although it sounds so simple, it's difficult. Not too difficult, but you can still can do it, but it needs some time. It's some time. The other one who difficult is secant cube. In the middle, you have this secant squared is just tangent x. But later I will tell you about this. But we focus on tangent first. We focus on tangent. Okay. Okay. How do we deal with the tangent? What will we do? Okay. You need to have using the substitution. Right? So you have sine over cosine, right? And sine and cosine is, you can cancel each other if you derive, right? And let me write this in terms of sine x over cos x dx, okay? And let the u is cosine x, so that I can have du is negative sine x dx. So this will be negative, and integrations 1 over u du. And 1 over u is becoming the ln, so this will be minus ln u. Or in our case, this will be cos x. But this is usually not in the default system. We need to remove the negative part. Okay? So if you remember that the cos is 1 over secant, and this ln 1 over secant, because this is ln 1 minus ln secant, I can remove the ln 1 and minus ln sec. Or am I right? Okay. It's too complicated. This is ln 1 minus ln secant. And this is plus c. So we have ln secant x plus c. Okay, I will stop until here. Okay, until here. Okay. So yeah, this is the tangent. If you have time, I will go to the secant and then secant cube, but I think secant cube maybe after we have the integration by part. Okay, maybe later. Okay, any questions first? Any questions first? Okay, any question? Okay. Yes. Yes, I think that's still okay. But usually in the textbook, it's not usual if you have the negative. So this is the one that usually approach, but still okay. Still okay. For me, still okay. For me, still okay. Okay. Let me review from the previous one. If there's anything that you maybe want to ask. Okay. So we learned the substitution method. Okay. In the integrations, this substitution is one of the easiest method that we will perform. There are other methods as well, and maybe in next week or next 2 weeks we will have more method to evaluate the integral. Okay. Okay. Any questions? Any questions? Okay. Okay. Hopefully you guys understand what the the subject is. Okay. It's still that you need to, like, you just write the notes without anything comes in mind. Um, if you're still doing that, I'm not sure whether you will be able uh, to learn more about the integration. So please let me know if you're having a trouble with that. Okay. I have some feedback questions, 2 questions and 1 survey. And I think I can show you. Let me stop the presentation and let me get back to. Yeah, you join from here. Okay. 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 I hope you guys joining. Okay. So we will have 2 questions and 1 survey at the end. Okay. Okay, let's start. Okay, let's start waiting for students to come. Okay, 24 students. I think that's enough. 25. Okay. Okay, let's start. Okay. I hope in your smartphone or in your laptop you can read the questions carefully. It should be the functions f, the capital F is equal integral from 2 to x of f of t dt. Okay. And the graph is function of small f, small f. The questions, which one is the largest value? Okay. This is to check whether you understand the question or not. Around 2 minutes, 1 minute left. Okay. Don't worry if you get wrong. I will show you how to answer this question. Okay. 10, 9, 7, 6, 5. Okay. 2, 1. Okay. Okay. Majority that guys get the correct answer. It's C. That is in the middle because that is the critical point, right? The maximum value. Okay. Get ready for number 2, the last question. Get ready. Okay, again, the graph, okay. We need to write the interval with bracket or without bracket is also fine. The number, comma, the number, and the interval. And remember, the graph is the small f, the graph. Okay, already, some students already submitted. Okay. Okay, 59, 58. After this question, we still have one more survey. Okay, 25. Oh, okay, everyone has voted. Okay, good. Yeah, it's -1 to 1. Or you can use the bracket or no bracket. I already arranged that. Okay. Let's see. Okay. Number 8. I need your full student ID to make sure. Is it 31008 or not? Or which one? Okay, please write your student ID on the chat box, okay, for the student, number 8. All right. Uh, last one, and last one. This survey, okay, survey. I would like to know, okay, from you. Okay. Left is disagree, right is agree. If you disagree that the midterm is difficult, you can select left one. Okay. Okay. Question number 4 or 5. This is related to do you still need more time to solve all, or if you get more time, you're still unable to solve? It's different. Okay, it's different. It's different. Sometimes you need more time because you write a long text or maybe write long calculations. Maybe that's need time. With number 5 is, although you have more time, you still cannot do it. Yeah, it's a different type of question. Okay, I need to know from all the students which part we are having, and this will be taken as consideration for the next exam. So I know which one we will have. Okay, that's why I'm at the beginning. I offer probably we will have a make up exam. Okay, to help the distribution on the class, okay, to help those distributions. Okay. Okay, if you guys are finished filling in the survey, then that will be the end of our lectures today. Okay, so if you have any questions, you can talk to me, or you can uh, send me an email. Usually some students giving me emails asking some particular problem. And I also probably will have attached some exercise, some practice for you. And not necessary to be an assignment, but maybe later I will have some assignments so that I know which part you are you understand, which part you are maybe still confused of. Okay. Okay, that will be that is the end of our lecture. So online students, thank you for coming. Okay. Uh, hopefully for the one who are not yet arrived in Taiwan or not yet coming to Taiwan Tech, we will meet you very soon, and I can help you to arrange the uh, the midterm for you, the delay midterm, the delayed midterm. Okay. Okay, that will be end of our course.